Nginx is the company behind the popular open source project trusted by more than 450 million sites. They offer a suite of technologies for developing and delivering modern applications. The Nginx application platform allows enterprises to modernize legacy, monolithic applications as well as deliver new, microservices-based applications. Check out infoq.link/Nginx for more information.
Hello and welcome to the InfoQ Podcast. My name is Wes Reisz and I'm your host. In addition to hosting the InfoQ Podcast, I chair a set of software conferences called QCon. If you're a senior developer, architect, or technical engineer or leader, QCon is the conference for you. Our next conference is March 5th through 7th. We'll have talks, panels, open spaces, and AMAs on things like large-scale event-driven architectures. We'll have architectures of self-driving cars, practical stories of reasoning about building, operating microservices, approachable lessons on AI and ML, people, process, engineering, culture, shipping the org chart, all kinds of things like that and more. 18 tracks across 3 days, 130 speakers. I hope you can check us out. On today's podcast, we're talking to Oliver Gould. Oliver is the co-founder and CTO of Bouyant. Before Bouyant, he was helping build Finagle at Twitter, and before that, he was in operations in infrastructure at Yahoo. On this podcast, we're focusing, kind of zooming in on service meshes. We start off by discussing what exactly are service meshes, what kind of services they offer, what they achieve, how they're part of the fabric of software today. We discuss some of the pain points that service meshes address, and then we move into talking about LinkerD and a recently announced tool called Conduit that Oliver's company Bouyant produces. As always, thank you for trusting us with your time, and thank you for joining us on the InfoQ Podcast. Oliver, welcome to the InfoQ Podcast.
Thanks, Wes.
So you left Twitter on a Friday, and on Monday you started this company called Bouyant. What was that like?
Stupid, probably. It was great. I really liked the tech I was working on at Twitter, and I really liked the team I had around me. But as the company grew, and it changed a lot in my time there, when I started, there were about, I think, 250 people. When I left, there were probably 10 times that more. And seeing the company change, I realized that I had learned a lot there, and I learned a lot about orchestration and Mesos and distributed systems and all of these things that I saw becoming much more practical in a containerized world where things like Kubernetes and Mesos are just dominating how people build systems. And so we thought we had a lot of lessons that we could go apply and help people in production.
So when you left initially for Bouyant, was it really to focus on like Finagle and kind of take that out to kind of the community at large? Or did you kind of always have this vision of where it is today?
I think the vision's evolved, but the essential idea was there. And so I'm an ops person by training and developer by need. So what I learned at Twitter was that these libraries we were working on, though they were really nice to program in, had a lot of operational value encoded in them. And when we had incidents, we'd remediate that incident by improving the libraries to not have these problems or to work around these problems or to be more graceful in failing in those environments. And so I really understood the kind of operational value of like, oh, if you're really going to this containerized world where everything's over a network, you're going to need this set of operational tools to actually deploy that and sleep through the night. And so we really focused on just taking Finagle and putting it into a proxy to start. And we really focused on that proxy to start. And so LinkerD is like proxy heavy, very configuration driven, but unlocked a lot of that operational value for dozens of teams to really get moving.
You just mentioned LinkerD, so that kind of bridges us into the conversation that I wanted to talk about today. This was a tough podcast to actually prep for because as I was working through here, you've done, Bouyant in general has done such a great job of kind of talking about service meshes and answering the questions about service meshes. But I kind of feel like we still got to start there and say, what is a service mesh? What do they offer? What are some of the capabilities? What are the tooling that we see in the space that's available? So let's start off. What's a service mesh?
Well, what's a service mesh is a really good question. And so I'm going to give you a very abstract answer to that. And so in a microservice, when you have communication over a network between application components, that communication, as I just said, it becomes very important operationally. And having tools to control and manage that communication are really imperative. And so I view a service mesh as the set of tooling that manages communication between microservices. There are various, incarnations of that. So I would argue that Twitter has a bit of a service mesh in Finagle natively. They can control traffic and they have a bunch of operational tools there. But what we've been seeing when you typically talk about service meshes, we're talking about taking all of that logic out outside of the application into the proxy layer where we can have a uniform way of doing this across technology stacks and across ecosystems.
That's exactly what I was about to ask. What's the distinction between tools like Finagle or Hystrix or Stubby and what we're seeing today with service meshes? Is it kind of that taking it out of the actual application and making it like a sidecar or a proxy? Is that the distinction?
Yeah, I see it a lot around kind of organizational dynamics and mandate, where Netflix and Twitter are able to say, if you work here, you're going to write software in this way with these tools, and that's how you get to production. In the real world, we can't really do that, right? And in the real world, companies buy other companies that have different technology stacks, and you change technology over time. And so that really pushes this need to not solve this in libraries for mass market. I mean, it works in small pockets of engineering ecosystems, but not in the world at large.
I guess the other thing, and what I was just describing, you're kind of like centric around a language. In what you just described, you used the word containers. So is it also that containers have sort of become the unit of deployment today?
Yeah, that's exactly right. Having the model, especially the Kubernetes model of pods, where it can have a unit of deployable, co-located processes, and containers being the kind of the packaging format in a way, and the runtime format, really makes that appealing. I mean, at Twitter, we use jars. Jars were our containers.
When we talk about service meshes, what are some of the tooling that's out there? Obviously, LinkerD is one of them. What are some of the tools that are out there that we commonly think of as service meshes?
I would say things like Finagle and Hystrix can certainly fall into that bucket as well, especially when you start tying them to services like service discovery services or other remote services. Obviously, LinkerD, but now in the last year, there's been just like a swath of new projects. So we've had Istio. I think the Kong Labs folks have been doing some things in the service mesh space. Nginx is now getting heavily involved, and especially around Istio and putting Nginx in Istio. So it seems like everyone's jumped on the bandwagon, basically.
Yeah, so let's talk about that. So you mentioned like Nginx. Obviously, service meshes do some things like that ESBs of the past have done. There's API gateways, there's kind of HA proxy. There's a lot of things that have been called a service mesh, or at least have features that are in a service mesh. Where do those kind of tools fit into this discussion?
I think they're all basically the same, right? They all solve the same problems. They're all proxies that do some form of routing and maybe have some extra sort of policy you can install there. The service mesh is really around putting this between every call and a microservice, right? Where you have all of these calls everywhere. And in our old architectures, we didn't have that many interservice calls. So we typically had a lot on the front end and then just data, big app layer and then database. And as we've decomposed those big monoliths, the communication overhead's increased a lot. And so you can build a service mesh with HA proxy and Nginx. And in fact, we've talked to many people who have. And they do that by deploying a bunch of configs via Puppet or Chef and bouncing the process. And they have these kind of systems that have evolved to satisfy the same set of use cases. But they're maybe not ergonomic to use. And you certainly wouldn't want to adopt one of these hand-rolled shell script-based service meshes en masse in production because it'd be really hard to support and operate. And so we're building more sophisticated service mesh implementations that have well-defined APIs that build into ecosystems like Kubernetes very closely so that you don't have this kind of hand-rolled thing that's backward-looking.
One of the big things that it solves, obviously, is this interservice communication and kind of addressing all the failure that can occur in there and a variety of different problems, observability, a variety of problems that can get in there. There's a ton of complexity to that. Is there a point where you don't really need a service mesh? Is there like a threshold that you cross organizationally?
This is a really good question. And I think where we've spent a lot of our last 6 months thinking about is, we've seen people go to production with LinkerD. And the first thing when you go to prod with LinkerD is you have to look and learn this config and figure out how to configure this. And as you do this, you see, I can configure 1,000 things. And so you try to configure 1,000 things. And it actually can be very complex to do that. This is not incremental. And so what we're really trying to do, especially with our new project Conduit, is focus on this incremental adoption and give teams the tools to start making the service mesh a thing that people want to use and becomes, I get value out of this, rather than a thing that you come to blame and say like, it must be this proxy's problem because I don't know what happened to my app, but something went wrong, so it must be the proxy. And so where we're really focused now is kind of that visibility. I think everyone needs visibility to know whether your service is running well, what its latencies are. Like these are things that your operating system can't tell you, your success rate, for instance, but we know at the traffic layer. And so we're really focused on that incremental, solve the smallest problem that you actually need to solve. And that tends to be visibility first, maybe something like TLS, but the actual needs for most service owners are quite small there. And then once you get that nailed down, it's a successful thing in your organization, you can start to add more complexity and more features on top of that. But we see a lot of people just try to turn all the bells and whistles on from the start, and that can be daunting for an organization to actually, deploy.
Yeah, absolutely. So you just mentioned Conduit. You've been talking about LinkerD for 3 years. Is that about right?
We've been working on it for about 3 years, but it's been public for about 2.
Okay. So now, just literally at the end of last year, you announced a new tool called Conduit. What is Conduit and how does it relate to LinkerD?
Yeah, so LinkerD is as I said, a very generic tool. It's configuration based. And as we started it, we're in a different world where there was many organizations were moving between Mesos and Kubernetes and Nomad and Swarm, and they had existing Zookeeper service discovery and trying to adopt console-based service discovery now. And so there's lots of migration and stitching things together. And so LinkerD is a really generic tool that's great at stitching multiple environments together. And so I can, for instance, prefer Kubernetes service discovery, and if I can't resolve there, fall back to Zookeeper, and if I can't resolve there, go to DNS or something. And that's all been very important in many of its use cases, is that flexibility. However, as we've seen more adoption around Kubernetes specifically, there's a few factors there. One is that being on the JVM, running LinkerD in a pure sidecar model where you have one of these per pod or basically per application process, that adds up quickly resource-wise, especially memory. And so I think the smallest we can get LinkerD down to is around 100 megs, which is quite small for the JVM, but quite large for a small micro host where you're running your demo cluster. And the other thing we saw is that that Kubernetes model is actually quite a bit simpler. The APIs in Kubernetes offer you a lot of primitives that we can just build into, that we don't have to have a pure abstraction over. We're in LinkerD, we want to have a pure abstraction over any of the environment. And so we really started to want to have a more tightly integrated system with Kubernetes. And to do that, we really wanted to tackle the resource costs associated with LinkerD at the same time. And so we rewrote the proxy. We now have a new proxy in Rust that's used in Conduit, and we have a control plane in Go. And so the other big lesson is that having to start your service mesh journey by learning a config language sucks. Like it's too much to learn to get started for what should be a really easy amount of value add, which is just turn the lights on, let me see things. So we're focused in Conduit of there is no config file for the proxy. You can only interact with it through a control plane, which is a set of APIs that runs in a dedicated namespace. And from there, and to even start today, there's no configuration. You can't configure anything. You turn it on, it works in Kubernetes, and you get stats out, and that's it. And over time, we'll add more control and flexibility into that, but you shouldn't need that to get started.
Conduit's fully open source, right?
Oh, yeah. Bouyant builds open source software. We don't have any proprietary software really at the moment. So yeah, LinkerD is 100% open source. Namerd is 100% open source. Conduit is 100% open source and will be and will always be. We're not going to put paywalls around queue sizes or timeouts or the various things.
So Netflix talks about kind of like a golden path. If you follow this golden path, you get certain capabilities. Is it correct to say Conduit kind of gives you, as long as you're accepting certain conditions, it kind of gives you a golden path on service mesh?
Yeah, that's exactly right. I think there are some constraints right now, and we'll loosen those constraints over time in terms of what types of applications we support. But yeah, our goal is to just convention over configuration. If you do everything a certain way, it should just work. And then if you really do need to go in and override things, well, we'll give you those escape hatches. But that shouldn't be the start of your experience, is to go turn all these knobs.
So what are the golden path? What are the cases where Conduit's a good fit?
As of today, gRPC and H2 are the only supported protocols that Conduit supports. We've focused on the hardest stuff first. But as of the release, which is, I think, going out later today, O2 will support HTTP1 as well, and as well some TCP-based protocols. And the following release, I think, in 0.2.1 or 0.3, we'll have a broader set of protocol support, so any TCP application can work. The trouble right now is with MySQL, which is not It's a special protocol.
And it's deployed with a sidecar model?
Yeah. And so what you do is you install the Conduit controller just with a kubectl apply, and that just will put the YAML in its own namespace. And now you have a running process, and it runs Prometheus as part of that. So that's how we use to collect telemetry data. And then when you're deploying your application, you can either manually configure your app to have the Conduit sidecar, or you can run this command conduit inject, which will just add the proxy into your deployment configuration as you deploy it. Yeah, and then we just add a little proxy. And the way that works is we then have a little init script, which IP tables all of the traffic coming in or out of your process through the proxy. So we get to see all the traffic before it goes anywhere. At that place, we can record telemetry on it. We're working on adding things like TLS validation and identity for free, so your app doesn't have to have any of that identity built in. We can just inject that for you and do validation for you as well. And then once we're there, we're in the place to implement timeouts and retries and all sorts of important operational primitives.
Very nice. As you were talking, you just mentioned two concepts that I want to kind of back up and talk a bit about. You talked about the control plane and the data plane. What does that mean?
Yeah, great question. So we talk about the data plane being the communication between your services, right? So you have service A calls service B. That traffic goes through the data plane. By the data plane, we're really talking about this proxy. If you didn't have a proxy, if you're using history or finagle, the data plane is the libraries that are managing that communication. The control plane is the set of services or APIs where we put all of the policy and configuration for that. And so what we think of in the control plane are things like service discovery, what IPs and ports are part of the service. We might think of things like routing rules. So when I see a request to this host, it's actually this other service instead. Things like timeouts policies and success rate information. All of the policy information should be stored somewhere centrally. In Conduit, that's actually built into the Kubernetes API. And so we'll be storing those things in the Kubernetes itself. In LinkerD, we have a control plane as well, which is NamerD, which is a route management process and does service discovery. And so you can use that to change the routing rules. But it's not as full-featured or as API first as I think we wanted it to be. It was a much more incremental approach. And so I think we'll be much more API focused on Conduit.
So one of the things that I just heard you say and I read that I find super interesting is that your control plane is implemented with Go and your data plane is implemented with Rust. That's really cool. Why?
So we've been looking at Rust for a number of years. So when we started working on LinkerD, Rust was really appealing. Coming from Scala and the JVM, having a functional programming model, we think lends to a lot of correctness. Type safety, I think, is very important, especially at this layer of the system. And we want to rely on these tools to build better software. And so we've been looking at Rust for a while, but in 2015, the ecosystem was super new. Like there was barely async IO implemented. And we realized if we were going to go build a proxy, we'd have to literally build the entire world to do that. Fast forward 2.5 years, we start to look at the ecosystem again, and we see that the networking libraries are actually becoming quite full-featured. Not quite to the level Finagle is, but starting to approach that. And so we realized it was a good time to start investing there. It was a good time to get involved because the ecosystem hadn't really solidified yet. So we can go influence it and make it work well for the proxy use cases especially. And so we've hired a bunch of people out of the Rust community who we think were especially good there to help drive some of that internally for us. That's Carl and Sean and Brian. And on the Go side, we want the control plane to be where people build into. And so in LinkerD, if you wanted to write a plugin, it's going to go into the data plane. And what we found there was that letting people put code in the data plane made it harder to debug and support the performance characteristics of the data plane. So what we want to allow people to do is put their policy as plugins into the control plane or to modify the control plane more. And so that's all Go, which we think is an easier place to get started. Rust is a bit of a learning curve, as I've learned, but I think it's worth it, or the value is certainly worth it. But on the control plane side, having Go, I think, makes it a lot more natural for people to get involved and contribute. Furthermore, we're developing that as a set of basically gRPC microservices in the control plane as well. And so our goal there is to allow people to write plugins in any language they want. And so if you want to write a plugin to Node or PHP or Java, go for it. Write that service interface and we'll let you plug in.
That's really cool. Yeah, Carl Lurch talked a bit about some of the networking capabilities of Rust and some of the things that I think you guys are working on at QCon San Francisco this past November.
Yeah, no, they're wonderful guys to have on the team.
Rust has got a super compelling story. It looks like C from the outside. What did you find with how fast you were able to iterate and cycle on code versus the learning curve with Rust?
Yeah, so I think I got quickly into expert mode Rust, which may have been a mistake. There are a few things I really had to focus on. First of all, the borrow checker and the memory model of Rust is very different. And I think I spent about 2 or 3 weeks really banging my head on that. And at the end of that, I really started thinking about programs differently. Sounds weird, but now I think a lot more around laying out memory and execution flowing over that memory layout, where before I used to think about the execution flow and just like putting objects through that flow.
You're working on JVM.
Yeah, that's exactly right. And so switching that mental model to be memory first took some time, but I feel like I understand my programs much better now.
I'm a Java developer, so what do you recommend for that person who comes from that type of thinking to overcome that hurdle?
That's a great question. I really, really like Rust type system. And so I think trying to learn and embrace Rust type system and not do OO is the kind of first big thing. And the best way to do that, I found, was to read other people's code. And the other big hurdle I encountered getting into Rust was adopting Tokio. And so Tokio is the async networking framework that Carl and some folks at Mozilla have been working on. And it's got its own model as well. So it's because it's doing async IO, where there's multiple tasks operating on a single processing core, we have to think about the notification model, and there's a bunch of other model on there that was actually really tricky to get right. And I think I only really learned well because one, Carl was super helpful on Gitter and was patient, was answering questions. But then two, when we actually started working together closely and doing code reviews of each other, is when all the lights really started to turn on in terms of, oh, I understand how this works. So I'm a little lucky to have that front row seat, but we're also trying to make that a lot easier. I don't think, hopefully in 6 months, you don't have to have this entire mental model to use the async IO stuff. It's just been growing as we've been building it.
I love the comment about read other people's code, because I taught classes at the university here for a long time. And as we train software developers, we don't do enough code reading. It's like every other industry. You go look at artists, what they did in the past, but in software, we like graduate people and say, hey, you're software developers.
Yeah, I think, pair programming code review were super valuable to me actually learning Rust. And what I've also found is that the community itself is really open to that. And so it's pretty easy to go find people who want to help you learn Rust because they're all crazy zealots. But no, it's good.
So one of the things that I know you wanted to talk about was not just the technology challenges with implementing a service mesh, but also the really hard bits, the people process. What are some of the things that you all have learned from 3 years now building service meshes that are the challenges with adopting this way of thinking?
As teams adopt microservices in general, we've seen a few ways that happens. And that can be either super incremental, where they have an existing monolith application and they're trying to whittle off pieces of it and shave that out into a new architecture. Or we see the boil the ocean greenfield approach. We're like, okay, well, pick the second system, Kubernetes, CI, CD, and they turn on all the features that they want in that new system and just target that and try to move everyone onto it. I don't know which one's actually better. I think they both have their trade-offs. In the incremental approach, you kind of get stuck in the middle sometimes. Certainly at Twitter, we got stuck in the middle for a couple of years. And I think in the other model, you basically may never actually get started because you may just build this perfect system and it doesn't actually mesh with reality. So where we've seen service meshes be most successful is in that incremental approach, where as a service mesh becomes one of the first things to introduce. And so we saw LinkerD become introduced very early in a few microservice adoptions. And as other technology decisions have changed, the service mesh has been what's enabled that change to be flexible. And so they don't have to reconfigure all the applications to work on Kubernetes differently than they did on Mesos. That change becomes okay, we'll reconfigure the mesh to paper over those details. And the other thing, as I alluded to before, is that we see people get a little feature hungry. They're like, oh, I'm going to go to microservices and we'll have CI/CD and we'll have everything, which is a good goal, but I think practically we're much more successful when you're being incremental. And the other thing I've realized here is that the people making a lot of these platform decisions are not the end users, right? So the application owners, people actually deploying their code every day and trying to use things, are the end users of the service mesh, really. Whereas the people deploying it are the platform operators who own the Kubernetes or Mesos cluster. And so we're in the interesting position of trying to give the platform operators enough good tools that they look like rock stars to their end users, to the application owners of their team. And so I think I try to think a lot about, I've been in that role before, but like, what are the things I'd want to give my users that make it much easier for them to not involve me in their day-to-day work? And so that's why I think things like visibility, I think, are really table stakes. Like, we have to give users enough visibility and tooling to just do their job without having to say, like, hey, is it my application that's broken or the Kubernetes cluster? Like, what's going on here? We have to be able to answer those debugging questions much more easily. And I think debugging microservices in production is just insanely difficult right now.
So this is where Prometheus comes in, right? That's just where you're feeding out data, and Prometheus allows you then to be able to analyze it. And I assume you have a tracing solution in there as well.
So we actually haven't implemented tracing yet because tracing requires application change. And so we wanted to really focus on no code change. Like, you can use Conduit, all of its features, without changing your application at all. We will introduce tracing, absolutely, but it's just not one of those like essential first features. The other interesting feature that we've put in Conduit, which I don't think is anywhere else that I've seen, is a feature we call tap. And what this allows you to do is basically craft a query of the service mesh and get results of that in real time. So I can say, I want to see requests that go through this service, maybe in or out, that have this path or have this host header or some property of that request. And then I can just start to get some selection of those requests printed to my terminal on demand without us having to log and record all requests to a centralized server. And so in the other way I think you can do this is basically put everything in Splunk or one of those tools and try to grep them out later. As we know, all of those logging systems are super expensive. And so we want to turn this around and actually be able to ask the mesh and say, okay, I have this question right now, tell me these answers. It's those sorts of introspection and debugging tools, which I think the service mesh really unlocks, that we need to be focused on the short term, because that's really going to make organizations use these things is, okay, I have a bunch of more things I can do in production next week before I get to some perfect architecture where we have authentication and policy and 1,000 things that you need.
But if your system then has a correlation ID or some type of tracing, then I can use that feature to be able to pull the request and be able to understand what happened across the entire mesh.
Yeah, that's right. And I will definitely have some form of tracing integration in the not too distant future.
And when you say that, you just mean like out of the box integration.
Yeah. And so if you pass these headers through your application, you'll get tracing for free.
Yeah, very nice. There's a compelling latency story that you've got with Conduit. What are you seeing with latencies as you're processing these requests?
Going to a native environment is a whole new world compared to being in the JVM.
You think?
So now we actually see our P99s are sub-millisecond. I think we're in around 600 microseconds. And I have a feeling we still fall down in some tests, or we just haven't invested a lot of time in scale testing yet. But we'll certainly get there. I think we've got the right ecosystem we're building into, where we have a lot of control over our performance profile, a lot more than we did before, at least.
What about overhead? How do you measure overhead when you're dropping a mesh onto kind of the overall system?
Yeah, so the first obvious one is memory footprint, right? Coming from the JVM, like I said before, we have a 100 meg memory footprint in LinkerD. In Conduit, we're quite small. The last time I ran it in Kubernetes, I think we were at like 2 megs for the proxy container with traffic, which is really, sounds too small to me, but I think we're in that under 10 meg range for memory right now. That may increase over time as we add more features in there, obviously. But memory-wise, I feel pretty good. And again, being in Rust, we have a lot of control over things like leaks. And we have a pretty good story for analyzing and protecting ourselves against those with a memory-safe language like that. And on the CPU side, I think there's a long list of things we can do over time. But really, our goal in Conduit especially, we want to be this small sidecar proxy. And so we're not focused on doing all of the traffic for google.com in a process. We're focused on doing enough for that a single process can do. And so we just need to be able to keep up with it, whatever the thing that we're a sidecar to is doing.
Absolutely. Okay, so I have to ask the $1 million question. So there's some LinkerD folks out there that are listening to this podcast going, wait a minute, what's happening to LinkerD? So what's going on with LinkerD versus Conduit now?
We have support contracts for LinkerD. We're still working on LinkerD. We're still doing releases on basically the same cadence. However, we're not pushing as hard on feature work in LinkerD. And so LinkerD work right now is much more focused on stability, correctness, improving testing, improving supportability, make it easier to debug things. And so that's where I think you'll see the focus of LinkerD shift to like, it's in production. We just need to make it better at being production, not make it do 1,000 more things that it doesn't particularly need to do. Where in Conduit, we're focused much more on the control plane and developing that feature set. We're focused on getting to production readiness quickly. We need people basically in production using it to get there, but we're focused on our kind of scaling and stability story there as well. But I think you'll see a lot more feature investment in Conduit than in LinkerD in the next 6 months.
So what are some of those features? What's the roadmap look like for Conduit?
Conduit, the first big goal I just mentioned in O2, we're focused on transparency and just opening up the protocol support so we can transit everything and add value on anything HTTP at least. We're working on some security-focused work here. So this is to establish kind of identity and have cryptographic security in your cluster by default. And so what we see is a lot of people deploy apps. They don't use TLS because it's just too difficult. Where I think we can basically get to let's encrypt for your data center. Maybe not in the full let's encrypt worldwide network, but like we can make your cluster secure by default much better than it is today. These are things I think we can do in the next month or two. The other big track of work here is getting this telemetry story really rock solid. So we have a lot of data right now, and that can be overwhelming for some people's production clusters. And so we need to give people tools to just get the data they need out of the system and not get super detailed information. Furthermore, the tap side of things, making it more queryable, more flexible for getting data out of the system, possibly even looking to payloads so we can ask questions about gRPC information or what have you.
I like the tap storing and being able to query the overall service mesh and be able to ask questions that you can see at the system level that, again, as a Java developer, I've always had to install some kind of third-party library plugin to be able to kind of see that detail or instrument my code in a way that I can see it.
Yeah, and you shouldn't have to know all of the questions you're going to ask up front, right? And so there's some questions you know you're going to ask, and yeah, we should always have success rate and latency and volume for services. But like, what's the status code for this specific path from this IP is a much more focused question that I only need to answer sometimes. And so I don't want to redeploy my code with log lines for that. I just want to be able to push a query into the system and get data out.
All right, Oliver, thank you for taking the time to chat. I know how crazy busy you are these days. So as always, thank you for chatting with us.
I appreciate your time, Wes.